Good evening, one and all. This is Farki from Sri Chhatrapati Shivaji Maharaj College of Engineering, Ahmednagar. The topic which I am going to discuss today is the future of cloud computing, part 2. So, when I come across a part Docker, it is looking like a whale, like a structure is being gone here. But this whale and the containers, which is nothing but containers here, is nothing but the data which you are going to use while transporting a data from one point to other point through a medium at some specific point. Coming to the part of a Docker as a part of a computer engineering application, Docker is nothing but an open source technology which was released in 2013, specifying that it must contain a package, then libraries and configuration. If I explain you this diagram here, the diagram is going to give you an idea about there is an hardware. Hardware here is nothing but the system. It is nothing but a computer or laptop or any other infrastructure which is engaged while sharing an data here, or while sharing or while providing it as a part of an infrastructure here. Operating system is nothing but more specifically, it works like an intermediator between the hardware and the set of instructions. When it comes to the part of the dependencies, library is there. Library is nothing but a set of structures which deals about how you are going to share a data, what sort of data you are going to use it. When a tool is being provided here, tool is nothing but it's some sort of a tool. It is like in what way it is going to give you an access regarding the sharing of a data, access regarding the specific orientation of specifying the arrangement of a data. Driver here is nothing but a driver is nothing but a set of software which is a mediator between the hardware and the software here. For example, if I'm speaking about USB, a USB is a hardware part, but I need a USB driver to consider a hardware part as a mediator. And in terms of a mediator with respect to driver as a software, it becomes a data sharer. That is a physically you're connecting to a USB part, and the physicality of that pen drive which is connected to your USB part is being checked or it is being verified by the softwares. That is a part of dependency. It means how I'm dependent. Application, in an application there's a code. Code is nothing but again the set of instructions which is being put on the execution of the specific tasks. Say for example, when I speak about instruction set is nothing but when such number of instruction sets are being coded at a time, we create an application. So with respect to code interfaces here, an application is being created, and for that application you need, after an application creation, in an application we define the working scenarios of a specific ideality of the application. Secondly, when we speak about the scenarios here, it also defines you that how your application is going to behave with respect to codes. And again, the behavior of a code is being identified and is being checked with respect to the scenarios of instruction sets. So the container is nothing but a combination of an application and dependencies here. If I speak about a container with respect to a technical terms, that too describing it in terms of a cloud, it is nothing but a runnable instances of an image. Now here a container image is nothing but what it is going to look like a registry here. Say for example, if I elaborate this diagram here, a client is there. Client has an idea about the Dockers, then Docker build, then Docker pull, Docker run. Docker build is nothing but you're creating it. You're defining it to some sorts of instructions here. When some sorts of instructions has been defined here, what we are doing is we are sharing it. We're sharing it with respect to a Docker daemon. And after that, when you're sharing that same information, Docker pull is what? It is going to call the same file which was being saved in terms of by a Docker pull. Say for example, I have created a file called abc.dr, that is a Docker. And if I want to call that file, I can put abc.dr in a Docker pull. Then it is going to give me a file. After getting a file from Docker pull, I'm going to execute it by in terms of Docker run. So here a straight line is given, that is I'm building it. After building it, I'm just calling it, whether it is a callable file or not. And with respect to its callable file, I'm again executing it. So here when I'm executing it, I'm just checking it whether the build of my Docker is really satisfying the need of my Docker with respect to its infrastructure or not. Secondly, when I'm speaking about the Docker as a host is what? Sometimes when we speak about the virtuality of the specific cloud or its working scenarios, Here, my host may be a virtual. Virtual means what? It may be run on a imaginary platform, or there is a platform which gives you an imagination about executing it at a one time. So yeah, this host is nothing but it gives you an idea about if I'm executing it, then to what extent and to from what point I'm calling it that specific file. Containers and images are again here. Containers means what? uh, that specific file which is being executed is being sent from a run to the Docker daemon. Docker daemon is what? It is going to store all the values or all the specific file which are being executed. He is going to store it. So after storing it, what it is now here a big question comes. What it is going to store? It is going to store an output file here. Because we are now least interested about the input, but we are more interested about the functionality of our output here. So when a container is being sent from this part, a container is going to load it. After loading the container is going to give an authentication to the images also. Then with respect to the images, replications of images is being stored with respect to n number of platforms of an images here. With respect to that part, some of the unique copies of that particular file is handed over to your registries. Now, when I speak about a handling of a registries here, means what? I am again sharing a file, that specific file, which is unique, which is not replicated, but which has a specificness regarding the execution of that file here. So, in such a way, a Docker works. A Docker works because what happens here? Till the date, we only said that there is a Docker, then there is a file, then there is an imaginary platform here, which is going to send and share the data from one point to another point. But what happens here? When we speak about a deploying of a file anywhere in a container, means what? Till the date, we are unaware about where that specific data is going to go. We don't know. How the data is going to store, we don't know. Where at what point the data can be stopped, we don't know. How the execution registers is going to go, we don't know. But we are keen interest in we are having a keen interest that somewhere you're going to store it. Somewhere you're going to store it. Whenever you are storing it, wherever you are storing it, what you are doing is a registry is being retained. Now again, registry here is what? It keeps all the activity, it records all the activity of every n number of file which comes to it. In short, it is a recorder. But here registry specifically saying in terms of recorder is what? Here a registry is going to maintain the timestamp of your file, the nature of your file, the executional pattern of your file, the cloud where I need to suppose when I supposed to store a file because I'm doing a file management also here with respect to inputs which I'm defining in terms of its domain and its execution of a domain here. So here, even if I'm doing this, I'm executing it. I'm storing it. When I'm storing it with respect to the informations of the file, creation of a file, modification of a file, content of a file, execution of a file, then executional pattern of a file, then the output of a file, so etc. These all terms are being stored here. Now, if I speak in terms of reverse engineering here, when I need to call a specific file again, now I want to call that file again. A client is there, say something after 10 days, I need to recall that same file again. What I am going to do as a client, I'll just send a pull information to my Docker's host. My Docker's host is going to check its run activity, whether it was executed previously or not executed previously. After that, when after that, when it is being going to get executed, then he's going to check its execution history. But if that history doesn't retains here in my Docker's host, then the Docker is going to check in the images file whether that file is present or not. If it is present with that file, then it is good to send it back to reciprocate the file again back. But if so that the file is not present here, but if so the file is not present here, then he is going to go for a registry and he is going to demand it. Now you may see to the left side, to the upward side of registry near the right side a containers or a Docker's images put up here. That Docker or that is a container is nothing but the infrastructure. That is why we have mentioned the diagram of the well and containers here. Means what? I'm storing a unique pattern on it. I'm storing a unique data here. With respect to its uniqueness, I'm storing all n number of different sorts of data, but which is not replicated, which is unique data here. So coming to the part of the concept now, what actually the Docker is going to have. So sometimes we do a standardizations of a packages of a software with respect to its dependencies. We may isolate. Isolation here is nothing but sometimes what we do with respect to one application, we expect a multitasking here. So every multitasking is being expected while executing it. So sometimes you have to isolate. In isolation, if someone says that what are the criteria of having an isolations here, the criteria of isolation here is nothing but first of all, the platform of your execution is what. Secondly, the type of a platform on which your isolation works is what. Thirdly, when you're using an app, what sort of multiplication, multiple authentications criteria are put. And third is share the same OS kernel. Now, usually what happens, some sort of when we speak about the sharing the same OS kernel means what, you are mostly preferring to the virtuality. You're more precisely speaking on a virtuality of that specific operating system. Now what happens when I speak about a virtuality again, to some extent when I say about a virtuality again deals with the imagination of a software here, because again there are a number of systems. One specific OS is being provided with respect to net OSs, and that net OSs is again is what is giving you the same infrastructure to use it in terms of the virtualization. Sometimes we also say that virtualization is nothing but the common existence which is imaginary but tries to manipulate the hardware with respect to that imaginary OS is my virtualizations. Say for example, sometimes we have to execute two different operating systems on one laptop. Then at that time you create a mediator. You create a mediator. That mediator is nothing but VMware, virtual machineware or VMware. That VMware is what is nothing but a software which works on the two different operating systems. It gives you an accessibility for two different operating systems but on the same hardware. Now again, when I'm coming to the part of an hardware, what again my hardware is going to do is whatever drivers are present in my hardware, that specific drivers is going to have a common access to that specific operating systems. Is going to have the common access. And secondly, working with all the major Linux and Windows server is again the second part. Now, if I define a container here, what my container is going to have, it is nothing but a Tomcat, it is nothing but a Java, it is nothing but Debian, SQL Server is there, .NET is there, Ubuntu is there, static binary is there, AI pipes are also there. But this particular different sorts of different applications are being interfaces with respect to the kernel, because your kernel is nothing but a mediator between the all n number of systems is there. And with respect to its mediator, what he is going to do is he is going to share it with respect to the Dockers. And that specific working is nothing but a mediations of between the two different criteria of systems here. If I define a container as a services now, there are developers who is a mediator. A build is there. Build is nothing but I'm developing some sort of different files from the same environment. Ship is nothing but I'm making collaborations between the two as a developer, as a build side also, and from the executional side also. And run is nothing but a deploy. Now, what happens here? I, being a client to left side, is creating all sorts of platforms here. With respect to it, I'm storing it in terms of image format or in terms of any password format. Then that specific files are being handed over to different number of systems while executing it. So there is again an engine running on a services in cloud or a data center. That engine is nothing but what? It is a runtime executable part. After execution of a file, he is going to hand over to a second server, assuming that that specific server is going to store the executable file. Assuming that it is going to store a specific file. Now, multi-container apps. Usually, why we need a multi-container app? Sometimes when we share some sort of file in a replicated format, some of your file may be get executed, some of your file may not get executed. When it is not get executed, they are terminated. They are terminated from the process. And some of the file which are being executed, they have been kept in the process for execution. Sometimes what happen? Multi-container apps is what? One of my app one of my container may give me an output, the other of the container may not give me output. Now, so this what why this happens? Because the definition for every container may be different, because the executional pattern for every individual containers may not be same, because we identify it with respect to the executional pattern which is being passed through your containers. And after the execution of it, what we do is we hand it over to the data centers, and data centers is what they're going to store it. They're going to store it. Now, this was my forward engineering, but if I reverse it, now what I'm going to do, if I reverse it, the reversing of my pattern is what in a data center executed file is there. A user requests the same file to run it again or to build it again. He is going to share it with the image source. Image is going to check it whether in my cache is it present or not present. If it is present, it is going to give you a back. But if it is not present, what he is going to do is he is directly is going to check send the request to the multi-container. Multi-container is going to check that whether we had the execution history within it or within us or not. If it's so, then he's going to give you an answer. If it is not, then he's going to check into a data centers. After checking it into with respect to data centers, what he's going to do is, with respect to the data center is going to check the registries, the indexing, the hashing, the linear hashing, the secondary hashing, the tertiary hashing of all the files present in it. And with respect to it, he is going to give you the specific runnable files with it. Now, why Docker was introduced? In 2004, the Solaris container said that there must be an introduction to some sort of cloud technologies which is going to put a filter on that specific file, because to avoid the replications. In 2008, Linux introduced a container for the cloud. In 2013, Solomon Hawks started a Docker as an internal project within .cloud. Then again, later in 2013, the Docker was released to an open source operating systems. When it was being released as an open source to some time until 2016, it was being declared by the commercial user that the Docker is nothing but the first commercial product which was being called as a Docker Enterprise Edition. And today, the number was still increasing. The number has still been increasing in the open source of the communities here. Now, advantages. Yes, it is an identical. Why it must be an identical? Because if you go for a replication, it is going to consume more time, more space, and every time he needs to execute the manipulated file or the replicated file to check the same existence of the result. So to overcome that part, they said that it must have an identical environment. So when an identical environment was being given, then at that time they deploy it. Then they ran the same way what they were used to have in the development of a specific file. They tested it, they produced it, and after producing it, they again check by deploying it. And after deploying it, they gave a remark. Okay, it's going to work in another format. Isolation environment for individual applications, we have it, because sometimes we speak about closed operating system source, sometimes we speak about open sources operating systems. So it depends on it how you are going to work on it. You have a version controls. Now, why we have version controls? Every time the need of a operating system or the need of a software changes, when the need of the operating system changes, we have to change the functionality of it. Because when we have to change the functionality, then at that time we are unable to modify at a runtime. So what we do, instead of doing a patching work, instead of adding some part then executing, small part again executing, small minute part again executing, instead of doing this part, what it happens, this will lead to the increase of your size also. This will work, but it is going to work with respect to dynamic format. So the working of a dynamic format is not up to mark, because you are because with respect to users requirement, you're changing the platforms here. And when the platform is changed, the every specific working scenario sometimes changes. And if you're patching it, means what? You're just adding some sort. You're just adding one point. You're adding second point. But adding of a point is again going to lead to the multitasking failures. That is why to have it a control on it, we have to change the whole version of it, because rather than going for a patching, we would suggest to work in a all-in-one criterias of your apps, all-in-one criterias of your apps. Second is portability. Now portability is what you can do is means you can use it anywhere. You can, there is no restrictions with respect to location, there is no restrictions with respect to mobility. Portability is what you can change the workspace of one system to another systems of a same platform, on the same platform. My platform here is nothing but an operating system which I'm using it, is my portability. If I'm porting it to some sort of my work, then my portability must support it. Secondly, developers productivity. Now developers productivity here is what, if you're executing it, what is the third bird eye view from the point of a developer? Because when you're executing it, how you are executing it, what was expected while executing it, and how your expectation is matched by the productivity of a developer. How? Third is your application agility, how quickly you can evolve. Now here quickly means what? What is the performance criteria? What performance you are using it? How you are mapping a performance? Where you are mapping a performance? When you are imposing it, how you are imposing that specific performance on it? And when you are imposing a specific performance on it, then what is the scenario of inspecting or imposing that specific performance on it? And secondly, it deals again with the functionality, the time taken by a system to check the functionality of that specific app. Operational efficiency is what? Sometimes it has to check that when you are executing it, whatever the content, with respect to the content which is being imposed on your application, really supports it with respect to efficiencies. Now, if I elaborate my efficiencies here, I will elaborate to say that what is my performance here. Operationally, if I'm defining n number of functionality on a specific file, then what is a unit of execution with respect to functionality? How I'm mapping the functionality here. This is the Docker's family. How it works like the family. Now, the Docker's family is what? If I elaborate to the leftmost part, there is an open source framework for assembling a core component that makes a container as a platform. When I speak about the container as a platform, now I am elaborating it in terms of Docker as per the enterprise edition and Docker as per the community edition. If I'm speaking about the enterprise edition, my enterprise edition deals with the commercial support. Say for example, if I speak about the Flipkart again, if I speak about the Flipkart, that Flipkart is what? It is going to share the enterprise edition because it deals with the commercialization of products and commercialization of delivery of that product. Secondly, what he is going to do is the subscription based commercially supports the product for delivering the secure software chain. Secure software supply chain is what? Again, when I'm sharing it, when I'm sharing some certain sorts of data here, how I'm sharing it with respect to enterprise, not with respect to customers here. When I'm sharing with respect to enterprise, what the content of that data is being shared to study the commercialization of the products for that commercial business. And for that specific part, we need an enterprise editions. Thirdly, there is a community edition. Now, community is what? Actually, we will elaborate a community here. A same sort of product is being required by a different people. Same sort of product. Say, for example, if I say that I have to use a Soap here is nothing but a common product, but that soap is deliverable to all the n number of people with n number of different location oriented persons. Means what? Again, I'm sharing a data. I'm sharing a sort of the community here, containers with respect to containers here, but it again depends to what extent the privacy is retained here. To what extent the privacy has retained here. Now, if I say the Dockers as an enterprise, now see when I'm speaking about a Dockers means what? Now here I am specifically saying that which specific companies uses a Docker in terms of their domains, in terms of their domains. So have a look at this slide. Have a look at this content. A service provider is there, which is nothing, maybe a telecommunication or a internet. AT&T, Sprint, Virgin. So these three industries are related to the service provider domains. Amgen, Merck, Optum, then Hinson Alpha. So these all three or four industries are related with the healthcare systems. Then I'm having a financial services here. With respect to financial service, Visa, we all know it that Visa is again a part of the Visa. We look at the ATMs also, at the credit card also. So again, there is a Docker again on it. Then these visas, Societal Generale, ADP, Northern Trust, then Goes and Nados. These are again the five industries which are only being related with the financial services. So here, even though the domains are different, but the use of that Dockers is same. Is same. Now here are technical parts are there. Genpier, RSA, TIPCO, Spunk, General Motors are there who are working on it. GRs means they are working on with respect to a specific domains called technology. When we speak about the insurance part, Anthem, Liberty Mutual Insurance, MetLife, and Mutual, these all are there again. And when I speak about the public sector, CDC, GSS, and Almaty University. So here, even though, even though the industries are different, the working sectors are different, but then also the working nature is same as it happens. So this was the end of the Dockers as part of it, and with respect to the functionality of a Docker in the future concepts of in the future of the cloud and the future of IoTs. So till here, it is almost the sixth unit is completed from this part by Dockers. Thank you everyone.